Hi everyone, welcome back to our YouTube channel InfinityGreedy. In our today's video, we are going to discuss about most frequently asked interview question on mud-sort. So let's get started and see those questions. The first question is mud-sort is dash not dash. So when I have already discussed this thing that whenever the question asks about the properties of any of the algorithm, so you should always remember in place and stable, right? You should always remember these two properties, that is in place and the stable algorithm. In place is what? Where we do not need a, okay? So in place is what? Where we do not need, no need of extra space. And stable means your order of equal element is preserved. Remember, and I have discussed about this that merge sort is a stable algorithm. For example, if you have 2782, this is first two, this is second two. So when you sort, you get this. This is first two and this is second two, right? And we have discussed how this algorithm works. That is when you divide it and then you merge it back, right? So merge sort is a stable, but it's not a in place algorithm. Why in place algorithm? Because you remember when we used to merge, we used to take a help of a temporary array b of k. We used to merge and we used to increment k, and then we used to copy this b of k element back to the original array. So we were using the extra space. So merge sort is a stable algorithm but not a in place algorithm. Okay. Now very important concept is inversion count. So question is, what is inversion count? So inversion count is nothing but it basically tells you how far is your algorithm from being sorted. Okay, how far or how many more comparison it might needs for you to get the algorithm sorted. For example, if you have 1, 2, 3, 4, 5 already sorted algorithm, okay, so in that case your inversion count will be what? It will be 0 because it is already sorted. You are at the sorted array. But in case if I talk about 4, 3, 2, 1, that is reversely sorted, right? So in that case, your recursive count will be maximum. So how you find 4, 3, 2, 1? So you need to check with this, you need to check with this 3 comparison. For this, you need to make 2 comparison. For 2, you need to make 1 comparison. So for this 4, 3, 2, 1, you will be having 6 comparisons. Then your array will be sorted. So remember that inversion count is nothing but it tells you how far your algorithm is from sorting, right? Now, what type of data set works best for the merge sort, right? So this we have discussed, right, in the advantages and the application that any data, large data set, okay, smaller data set. See, when the comparison comes for smaller and the large data set, I will say that it works well for both, but we have other algorithms. But it is nothing like if I use this merge sort, it will be a problematic or it will increase my time complexity to n square. No, it's gonna take n log n only, right? So in that case, I can have large data set, smaller data set, organized data set, unorganized data set. It can work on all kind of data sets. But when you ask some of the things like, is it should I use it for smaller data set? When I have other algorithms, I will say no. I need to check because it takes n log n. If I have something less than that, I'll definitely gonna use that, right? That is why merge sort works for all data sets. Okay, but we have the other algorithms which can be utilized for the smaller data sets. Next question is merge sort can be used by different data structures. So this is a very important question. So if you remember, we were talking about the linked list. So the question can be, can merge sort be used on linked list, right? So let me give you the fundamentals, right? See, You understand? Since we can merge sort can be easily utilized by the queue, there is an issue that needs to be tackled to do so, right? But in the linked list, the nodes are not stored in what? In contiguous memory location. Remember? What is the problem if those nodes are not stored in the contiguous memory? We cannot. So if I'll write it right. So when I talk about linked list, what we do, we nodes are not stored in your contiguous memory location. So what happens? They cannot be accessed using the indices of the array. So to enable random access to an element, we have initially map indices with the pointers. That is why pointer concept for the linked list. Are you getting it? Are you getting it? I'll just repeat it again that in the linked list, the nodes are not stored in which memory? In the contiguous memory location. So they cannot be accessed using indices as an array. To enable random access to an element, we have to initially map indices with what? What we do in linked list? Pointers. As simple as that. So it is good. We can use with the linked list, right? But we need to be careful. As simple as that. When does the worst case occur in the merge sort? This is a very good question, right? Because why we say n log n is for best, average, and worst case. So exactly when worst case happens. So the worst case of a merge sort will occur when the number of comparison is maximum. Now, what is the number of comparison is maximum? So in merge sort, the number of comparison between two subarray is maximum when the subarray contains alternate elements. For example, you have 1 comma 3 and 2 comma 4. So these subarray contains alternate elements of the sorted subarray, correct? So when you do this, what you will get? 1, 2, 3 and 4. So you will have a maximum number of comparisons. Are you getting it? So this is what a merge sort worst case occurs when you have the maximum number of comparison, that is your alternate elements of the sorted array. Correct? Any doubt here? So these are the most frequent questions being asked, right? Many a times I have seen they ask you to write a program on inversion count. So we can discuss more about inversion count in our videos. So if you like this video, please do like, share and subscribe. Thank you.